All right, so questions? All right, let's look at the next ODP. So let's look at the ODP you just finished, 203. Get node. It's actually shorter than the init function for 202. Define your struct node. Again, you've got to define your struct node in your file. Okay, either explicitly in code or in a .h file that you include or something, but that's got to be set up. And then get node just takes an array of struct nodes, loops through from 0 to 100, looking for a valid flag equal to 0. As soon as it finds a valid flag of 0, it can return at that point. You could save it into a flag and then at the end of your loop see if that flag's been set and so on. But in general, if all you're going to do after this is return the value of I, you may as well just return right there. And then if you come out of your for loop after that last curly bracket, it means you did not find a node with a valid flag equal to 0, so you just return your -1 flag at that point. So that's get node. 204 is something we can call get first, and this is not actually something you're going to have to use in PA1. But you'll be doing things similar to this, so it's kind of a warm-up for some of what else you might write for PA1. Get first basically returns the data value of the first data node in your linked list. Okay, and remember there's a sentinel node in the beginning. So we have a sentinel, and that might point to a 10, and that might point to a 15, and that might point to a 20, and that's the end of the list. Get first should return the number 10. Okay, you're passing it this array of struct nodes which contains this structure. It should return that number 10 because that's the first data node. And that's not necessarily the thing that's stored at index 1 in the array. In fact, I can guarantee in most of the tests it's not what's stored at index 1. It's what's stored at whatever index is specified by element 0's next entry. Right, so element 0 is a sentinel node. Its next field has an index in it. At that index, the data value is the value of this first node. Unless the sentinel node's next field is -1, in which case your list is empty. There's no data in it. Okay, so you call get first with two things. You pass it the array of struct nodes, and you also pass it a pointer to an integer, which is going to be used to return an error flag. All right, get first itself returns an integer, which should be the data value of the first node in your linked list. Data values could be positive, negative, 0. We can't use a particular data value to mean the list is empty, right? Because -1 is a perfectly fine data value. So in order to know whether an error occurred, we're passing a second variable, which is this error, which is a pointer to an int. So here's the full behavior. LL is an array of struct nodes, which contains a linked list the way that we've been talking about linked lists. LL0 is the sentinel node and is always present and is always meaningful. Okay, so it's a properly constructed linked list. LL0.next is the index of the first data node. If there is a first data node, go to that index, find the data value, return that as the function's value, but also set error to be equal to 0. Okay, And since we're saying integer star error, if you want error to be equal to 0, you have to say star error equals 0. The parentheses are optional, but illuminating, right? So if you said error equal to 0, you're not going to change anything in the calling program. Error is a pointer. This says take the thing that's pointed to by error and set that equal to 0. So now in the main program, if the main program calls with a second argument of ampersand error, this will cause main's variable error to be equal to 0. All right, so this is how we pass things by reference in C. And if in your get first you find there is no first node because the list is empty, then you should set the value of error to be equal to 1. And so main will call get first with an array of struct nodes and the address of an integer. And when it returns from that call, that integer should have a value of 0 or 1. If the value is 0, then the return value from get first is the data value of the first node. If the value of error is 1, then get first should return a 0. But again, you could have a list where the first node is a 0. So seeing that 0 is not enough to say there's an error. So make sure you set the error code to be a 1. All right, standard test bed, standard way to build the image, and then how to assess. So questions on that? Okay. Let me go ahead and do an attendance sheet just to see who's here at the end of the week. Say what?
A lot of people really care about showing up.
Yeah.
Just to make sure on the ODP, we are returning the data value.
You're returning the data value, yes, not the index. All right, so let's talk some more about how we do PA1. How do we work with this array of struct nodes and think of it as a linked list? So let's make a list. So there's a 10, 20, 30, and that's the end of our list. And 0 is always a sentinel node. So it's valid. We don't care what the data is. I'll set the data to 42 just for kicks. So there's a possible table for this linked list. Sentinel points to index 2, that's our first node, which is a 10. That's followed by index 1, which is 20, our second node, followed by index 3, that's 30, our third node. and that's the last node because it's not followed by anything. There's a flag saying there's no node after this. So how can we print the data contained in this linked list? What if we wanted to write a print function that takes this array and prints out the list in order, right, by following node to node? Let's think about pseudocode, not be bound by C itself. What's the general algorithm here? If somebody handed you this array and said, can you tell me what the list looks like? What are the steps you would use yourself to figure out that this is a 10 and a 20 and a 30?
Follow the next.
Okay, follow the next, starting with 0. So I'll do start equals 0. And then I want to follow that, right, and say something like, I'll call it node. And look at list bracket start dot next. So this is the index of next node. Okay, or it might be something else other than the index of the next node. What might it be? It might be -1. If I have an empty list, this value right here, instead of a 2, it's going to be a -1. So I could say if node equals my null, let's just return, we're done. We've hit the end of the list. Otherwise, node is the index of the next node. So let's see, there's a few different ways to do this. Okay, we definitely want to print list bracket node dot data, right? It's the data value of whatever the next node is. So if we start off with this, start equals 0, node will be 2. It's not equal to my null, so we'll print list bracket 2 dot data. That's going to print out our 10. Okay, so how do we get to the next node? Yeah, so we want to look at list bracket node dot next. So this is the index of the next node, or maybe my null. So go back up here. Now you can clean this up. I didn't have to use start. I could have used node up here, then I could just branch back up to this line. But this might be the way you develop it, right? So let's see if this works. So this is where we play computer, right? So start is equal to 0. Node equals list bracket 0 dot next. Well, list bracket 0 dot next is equal to 2, so node is equal to 2. If node is equal to my null, return. It's not. So we're going to print list bracket 2 dot data. Okay, list bracket 2 dot data is a 10. So here's what we're printing. We're printing a 10. And then it says node equals list bracket node dot next. Well, node's equal to 2, so this says node equals list bracket 2 dot next. List bracket 2 dot next is a 1. So this changes node to a 1, and we come back up here. If node is my null, return. It's not my null, so we're not going to return. Print list bracket 1 dot data. List bracket 1 dot data is a 20, so a 20 gets print. And then node equals list bracket 1 dot next. List bracket 1 dot next is 3. So node changes to a 3. Go back up here. Node is not my null. Print list bracket 3 dot data. That's our 30. Gets printed. Node equals list bracket 3 dot next. List bracket 3 dot next is minus 1. Go back up to the top. If node is equal to my null, return. Well, it is equal to my null, so we're going to return. But you know what? Let's print a new line so that we come down to the new line there before we return. And then we exit our print function. So you look at your list, you look at your structure corresponding to the list, implementing the list. You spec out some code that feels reasonable, and then you pretend you're a computer and you execute it. Right? And in this case, if this was my array, this is my list, it does in fact print 10, 20, 30, followed by a new line. Okay, and then try an edge case. Suppose that index bracket 0 dot next is minus 1. Well, start equals 0, node will be equal to minus 1. If node equals my null, it'll print a new line right away and return. Doesn't print anything, that works too. Now you code it up. Right, you write actual C code, you use double equals for the comparison, you put in brackets and parentheses and all that stuff, and make yourself an array like this. Right, you did this in your init function, so you can just make a struct node of 100, an array of 100 struct nodes, and list bracket 0 dot data equals 42, list bracket 0 dot next equals 2, list bracket 0 dot valid equals 1, list bracket 1 dot data equals, and so on. Yeah, it's a bunch of writing. You know what? It's a really good chance to practice using VI. Because VI is really good for taking a line and making copies of it and then just changing a few pieces of it if you know how to do things like change word with CW or P to replace the last thing that you just put, and so on and so forth. And once you've made a section of C code to create an initial linked list, you can use that the rest of the next week, right? You can use that for everything you're doing in PA1. Because you'll throw that in a function called myInit, and when you call myInit with LL, it makes a little linked list for you. And now you can use that to test your search function, your delete function, your insert function, and so on and so forth. And seriously, if you write code to do those 12 initializations and then set these to 0, right? Use that as an excuse to practice some VI, right? Find a VI cheat sheet. There's one on Canvas. I've given you some VI commands last quarter, and see if you can do something more than just use it as a glorified notepad. Right? See if you can learn some of the commands for actually manipulating fields, and if it starts making things a little faster for you. And if it does, cool. If not, and you want to stick with gedit, that's fine. But, you know, this is your time to sort of like play around with your tools and expand your collection of tools in your box. And so that can be a good chance to work with that. All right, well, if you can print, you can search. Right, so search is going to look almost exactly the same. Except we're going to pass an integer. And instead of printing list bracket node dot data, we can say if list bracket node dot data equals n, return 1. Because guess what? We found a node whose data value is equal to n. If we come down here and node is equal to my null, just return a 0, saying that data n was not found in our list. So you can hack this function up to make your search function with just a few changes. And if you know your print function works, your search function should work. And if it doesn't, it's probably something small. It's not a fundamental logic error. It's not an error with how you're working through the data structure. It's, you know, you did equals n instead of equals equals n. Or you forgot to return 0. You just said return or something, right? So you can do print. You can do search. We talked about delete yesterday. Let's talk about add. Let me make sure. It's called add instead of insert.
It is called add.
Is it add? And it just takes a array of struct nodes and an integer?
Yes.
And it returns a 1 or a 0?
I believe so.
Yes, okay, good, good. Alright, we'll pass a struct node array. We'll pass an integer to add, which I'm calling num. And we're going to return a flag. So we're going to do the same thing we did with deletion. We're going to have a pair of indices, which represents some node and the node following it. And I'm going to think of this as you know what? Let's do it a different way. Let's just use a single index, because sometimes people try to do that. So let me just make a single index called node, and we'll initialize node to 0. And what is node? The way I'm using node is, should we insert immediately after node. So pictorially, I'm thinking of node as one of the nodes in our list, starting with the sentinel node. Implementation-wise, it's an index in our array, so it's initialized to 0 because that's the index of the sentinel node. But logically, the way I'm thinking of this variable node is a node after which we might want to add our new number. Okay, and I want to move through my list until I get to the point where node is the thing immediately before where I want to make this addition. So let's pretend that I'm trying to do an add 25. So the first thing I want to do is I want to have a loop whose whole purpose is to move node until node is sitting right here at this 20. Okay, now how do I know that the 20 is the node I want to insert after? I mean, we know it because we're smart.
You're inserting less than 30, so less than its the next data.
Yeah, if it's greater than that node, and less than.
Okay, so if the node that we're going to insert is less than the following node, the node after node, right? So if this is node, the following node is 10, 25 is not less than 10. So move down. Node is now the 10, the node after it is 20, 25 is not less than 20, so move down. Now node is the 20, the node after it is 30, 25 is less than 30. So we stop right there, and we say we want to insert after the 20. Well, that's worthy of a comment. Move down our list until the node after what we're calling node is bigger than our number. Oh, and what if it's equal to our number?
Already existing list, and you know.
Already exists in list and we should not add it. So I'm going to put a comment here for myself and say make sure num isn't already in the list.
The one issue I noticed with that was you wanted the main to return a different message for that.
Mm-hmm.
And if you hide that and add, you're not going to know that if you're only returning a 1 or a 0 from add. And so I thought either, maybe I'm misunderstanding something, but either we should return a different value so that the main program can know, or we should fence that in the main, is what I was thinking. But
So 0 if it's not successful.
because you said there was no space, but it also could be unsuccessful.
Ah, right, okay.
It's a duplicate. So I was planning on doing it in main.
Okay, yeah, okay, that's a good point.
Or just return a 2, or like a negative 1 or something. It's a duplicate.
Yeah, so your main program has to distinguish between I didn't insert because I was out of space, or I didn't insert because the number was already there. So yeah, what you're saying is right. Probably in your main program you want to make sure that the number's not already in the list. In here, I would just go ahead and say if it's already in the list, just return a 0, which is the error code. Or if you're out of memory, return a 0. But in your main program, don't call add unless you check first to make sure it's not in the list. That's potentially confusing. But make sure your main program does the right thing. All right, so if I want to go back and add that, sometimes what I do is I put a comment in my code and I put the words to do in uppercase with no space in there. And I put some asterisks around them so that I can spot them. And then I can go back later when I think I'm done and just search for any comments that say to do, and it'll tell me, oh yeah, I got to do something else.
Can you just call the search function first?
Yeah, so all I got to do in here is call the search, and if it's returns a 1, then just return a 0 from here. All right, so let's move down the list until the node after node is bigger than num, or we get to the end of the list. Because if we were trying to insert the number 500, we're going to get to the 30, that's the end of the list. We still haven't had this condition satisfied. So, or we hit the end of the list. So I'm trying to think out what I want to do. I haven't actually written any code. Well, I wrote node equals 0. But I haven't really written any code yet. I definitely haven't compiled anything. I'm really thinking about the algorithm, thinking about the steps that are going to get me there. And after we write some pseudocode, I'm going to work through that with some examples and convince myself that pseudocode is right. And then I'm going to write some C code to implement the pseudocode. And then I'm going to type it in to the editor, and I'm going to compile it, and I'm going to start testing it. Okay, but that's way down the road. I'm really thinking algorithms right now. Okay, well, if node is pointing to a node and I want to know if the data value that comes after it is bigger than num, that looks something like this. If list bracket node, well, list bracket node dot next is the index of the following node. So I really want something like this. Now that's more confusing than it has to be. But what am I saying here? Node is the current node I'm thinking about. List bracket node dot next is the next field. That's the index of the following node. List bracket that index is the following node. Dot data is its data value. So if that thing is bigger than num, then I want to insert after element node. But there's a problem in here. which is if list bracket node.next is -1, this is going to say, look at list bracket -1, that might seg fault. So first thing I'm going to do is say if list bracket node.next equals my_null, then I want to insert at end of list. That's the case where node was right here and I was adding something like 35. And so list bracket node.next is equal to -1. Okay, how do we insert at the end of the list? If node is the last node in the list and we want to add something after that last node, what kinds of things do we have to do?
Gotta get a new node.
Got to get a new node, which we always have to do. So we may as well do that in the beginning. So next equals get node list. And we'll want to do a check to make sure that we're not out of memory. So if next is equal to my_null, we're going to return a flag. Okay, so next is an index for a new node. And node is pointing at the last node in the list, so how do we tack that new node onto the end of the list?
Well, that it's next, so the last node's next. You want to change from my_null to be the index of the node you're adding.
Okay, so if we're at the end of the list, list bracket node dot next should be equal to, I shouldn't have called it next, I'm reusing my words. Set it equal to the index of this new node, right? And then set this new node's next field to be equal to my_null because it's the new end of the list. And when we got our node, we also wanted to set its data value and its valid flag. Does getNode set the valid flag for you? I have a feeling it does. Yes. So we need to set the data value, so list bracket next dot data equals num. So we got next, that's like a 4, and we set the data value equal to 35, and we set next equal to, we set nodes next equal to that new index, and we set next equal to my_null, and we can just return.
Do you care if I didn't set the valid flag in the get node and set it in the add instead?
Yes. Yeah, definitely set it inside get node. And then return 1 because we succeeded. So that's all an edge case. Okay, that's all a case where we're moving through our list and we got to the end of the list and we hadn't done our insertion yet. So we're just adding to the end. But let's look at our general case where we're adding 25. And so nodes equal to 0, and we check to see if list bracket node.next.data, which is 10, is bigger than our number. And we can break this into steps, right? We could say index of next node equals list bracket node.next. And then we could say if list bracket index of next node.data is bigger than num. Right, so we can break this down logically. So 10 is not bigger than 25, so what do we want to do? Just move down the list. So we change node to be right here. And then go back up here, see if you're at the end of the list. If you're not, well, node is this node right here, so list bracket node dot next is this node, and list bracket that node dot data is going to be 20. If 20 is bigger than 25, well, it's not. Our insert goes in there. It's not, so we're going to say node equals list bracket node dot next. So node will change to this node. And we'll come back up. List bracket node dot next. Well, it's this node, it's not my null, so we'll skip that. If list bracket node dot next, well, list bracket node dot next is this node. Its data value is 30. If 30 is bigger than num, which is 25, it is. So we want to insert after node. Okay, so we have a bunch of code here that goes in this if statement. And it looks a lot like the code we just wrote up here. So let's suppose next is equal to 5. We already set its data value to 25. We already set its valid flag to 1. Node is equal to this node, so node is equal to 1. Next is equal to 5. And we've loaded a 25 in here. So how do we add the 25 right after the 20? Forget the code. What are the logical steps? Forget about the code for a moment. Just think about this structure here. We want to insert a new node at index 25 right after the node at index 1.
We need to make 25 point at 30 and make 20 point at 25.
We need to make 25 point at 30 and then 20 point at 25. So 20 goes to 25, 25 goes to 30. Okay, how do we know that 25 should point to 30?
Less than 30.
Just looking at the table here, how can we tell with the variables we've defined, right, node is equal to 1?
Because 20 is pointing at 30.
Because 20 is pointing at 30, right? Node has a next value of 3. That's the node containing a 30, right? We want our new node's next value to be equal to node's next value. So new node, what are we calling it? Next. List bracket next dot next equals list bracket node dot next. Okay, list bracket node is this node here. The next field says where it's pointing to. That's what we want to set our new node, which is list bracket next. We want to set its next field to. So list bracket next dot next, that's this box right here, should be set equal to list bracket node dot next, which is this box there. This should become a 3. So now our 25 is pointing the same place that node is pointing. And then we want to change node to point not to the 30 but to our new node. So list bracket node dot next equals, well, it should point to our new node, which is index 5. That's just next. And pick better variable names than I picked. Index of next node as opposed to just next. Index of current node instead of just node. All right, so we changed 25 to point to a 30. We changed 20 to point to a 25. We loaded the data value up here. We've set the next field here. We've adjusted the next field on node. Are we done? I think we're done. Return 1. Okay, so the reason I'm going through this is not to get this code so that you can copy this down and type it in, right? I don't want you to take this code and type it in. I want you to repeat this process on your own, right? Or with friends. It's really good with friends. Repeat this process of making a list and then working through the steps of how do I figure out where to add a new node, and then how do I adjust things in this data structure to put that new node into the list, either in between nodes or at the very end. And if your node's going in the beginning, this code will work exactly as it is because of the Sentinel node. It just looks like you're inserting it right after the Sentinel. So there's no edge case there. So think about these steps, spec out some code with better variable names, and then work through a couple of test cases. Right? Maybe start with an empty list and add a 10 and then a 30 and then a 20. And make sure it ends up being 10, 20, 30. And then once that works, write it up in C, do some tests. And at this point, you've already got a print function, and you've got an init function, so you can make a linked list, an empty list, just make a struct node array, pass it to init, that should give you a Sentinel node pointing nowhere, and then call your add function, add a 10, call your print function, and it should print 10. Now call an add with a 20, call your print, it should print 10, 20, call add with 15, it should print 10, 15, 20. All right, and then you're pretty much confident that your add function works. But add a few more things, add something in the beginning, add something at the end, make sure. Does this seem doable? Yeah, cool.
I had a question about release node. Did you want us to do the search inside of release node, or do we? Because you said int number. Is that the index?
That's the index.
Oh,
Yeah,
that's the index.
yeah.
Okay, because the rest of them were all at number and they weren't.
I should
data.
specify that better. Yeah.
That makes it a lot easier.
I'll update that. Yeah, it should just be an index.
Do you care if I did it the other way and don't change it?
No, I definitely want to take an index.
Okay.
So if you're thinking ahead, PA2 is going to be exactly like PA1, but with dynamic memory. So instead of get node, we're going to call malloc. Instead of release node, we're going to call free. Okay, and we're going to basically replace the index with the pointer to the node. And then all of this stuff, list bracket node dot next, is just going to become list arrow next. And it's going to be a really sort of easy transition. All right, we talked about delete yesterday. We've got add, we've got search, we've got print, we've got init. We're pretty much done. Right, that's PA1. The only other detail is the main program. And like I say, you've done this in 224, but since we have a few minutes anyway, what does main do? Initialize the linked list, print a prompt, get a string. If it's I followed by a %d, call add. You can't just see where I'm writing. All right, initialize your linked list, print a prompt, get a line of characters from the user, parse it with scanf. If it's an I followed by an integer, call your add function. If it's a search followed by a %d, then call your search function. If it's a d followed by a %d, call delete. If it's a p, call print. If it's an x, return. Otherwise, print out a help message. And then go back up here. I feel like I missed a function, but add it if I did. That's basically it. One big while loop. You can while forever if you want. because when we say X, we can just return right there. Or you can set a flag, say, well, the flag's not set. But use fgets to read in a line of text. Don't use scanf, right? Use fgets so that now we have a character array, and now we can parse it a bunch of different times to see if it's in the format of I followed by an integer, S followed by an integer, and so on. And you're done. All right, so so do the ODP. Make sure you have a GitLab repo set up, and plug away on PA1. I think everybody knows enough at this point to complete PA1. So make as much progress as you can. Let's see how it goes. Hopefully, I will see you on Monday, but we will see what happens. And if not, I will see you sometime after that. Thank you.